So in this video, I want to show an example of how to do a matched pair design. I previously posted a video on how to do this by hand. In this video, we're going to actually use Excel and a little bit of Crunchit to get through this activity. So the question or the problem that we're looking at is 20.11, so chapter 20 in the textbook, and it involves eye grease, which essentially the question that they're asking is, does eye grease work? So that's that black stuff that you put under your eyes. So in this particular study, they took 16 students and they did a test where they were facing the sun for 3 hours, and they did it once without the eye grease, and then another time they did it with the eye grease, with some time in between for their eyes to adjust, and so that we could have an accurate view. And so these numbers represent each of the students, each of the 16 students that were measured, and the numbers themselves are the difference between the sensitivity with the grease and without the grease. So these are just the differences between those two numbers. And so the question is, does the data in this example, does the data support the idea that eye grease actually does increase the sensitivity to contrast? So I've set up an Excel spreadsheet here, and it looks a little busy, I know, but I'm going to walk through the different pieces of this spreadsheet. So the stuff in yellow is stuff that can change, and some of the stuff I've just laid out for the sake of time. So here's the question. The question is just restated here, and this is our data set put into the table. So I basically just taken these 16 items here and just put them into the cells next to this so that we can actually run some calculations on them. So in our process here, we want to follow the steps that we've been following for all these other problems. So the first thing we want to do is ask, what is the question that we're trying to answer? And the question we're trying to answer here is, does eye grease help? So is it effective or is it not effective? And our null hypothesis is going to be that it is zero. So there's no change in sensitivity to contrast. The alternative hypothesis would be that there is a change, meaning that the change is greater than zero. So it means that there was some sort of change in the sensitivity, and it probably would never be less than zero in this particular study, just because of the nature of the data. So I've defined my hypothesis. I've defined the question that I want to ask. So the next thing I want to do here is I want to set a significance level, and I know this is step 5. It really, doesn't matter whether you look at the outliers in the single peak prior to or before, after, but I'm going to just pop right down here to the sensitivity level. So we're going to set this at 0.05 or 5%, which is sort of the gold standard for significance levels. Could be less if you wanted it to be, but we're going to set it at 0.05. And now I'm going to go back up here to the question about outliers. So first and foremost, I want to graph or chart the data. And so I've used a stem and leaf, and this is the stem and leaf here. Now I used Crunchit to make the stem and leaf, but you can do this by hand as well. In Crunchit, if I go to the data here, I can simply, this is my data. I can actually sort this data. So now I have it in ascending order, and I can run some tools on it. So one of those is some charts, and I'm going to use stem and leaf, and I'm going to choose my sample, which in this case is diff. It's going by the column header here, and I'm going to have it automatically generate both the leaf and the stems. So if I put a 0 in these, it means that it means to automatically figure it out. And I hit calculate, and this is what I get. So you can do this in Crunchit. And there's also a bunch of other tools that I will get into at a later date, but they're much more sophisticated and a lot harder to use, so we'll probably avoid them for this class. So now I have that that information, and it looks like there might be a couple of outliers. This 3 and this 4 seem to be kind of on the tail end. So I probably want to do a little bit more work on this data set just to make sure that we don't have any significant outliers. So I'm going to go back to my spreadsheet, and based on this, I'm going to do a little bit more analysis on the outliers. So up on the top here, the first thing I want to do is determine what is the acceptable range of values to be considered not outliers, and what happens, what's that magic number that it needs to be less than or greater than in order for it to be considered an outlier. So I've kind of laid this out right here. So we are going to determine the interquartile range, and then we're going to apply that interquartile range rule to both the low end and the high end of our data set. And so anything less than whatever this number that we come up with, anything less than that or anything greater than whatever this number is, will be considered an outlier. So again, I've used the tool Crunchit to do this, but you can do this by hand or you can do it in Excel using a formula, however you want to do it. But in this case, I'm just using this for the sake of time. And I'm going to use descriptive statistics. My columns are diff, which is the name of the column there. And I'm just going to click calculate. And so what this does is it comes up with all this data right here. And we can plug that data back into our 5-number summary up here, which I actually have already done for the sake of time. So you can see here we have all the data to calculate our IQR. So our interquartile range is just going to be Q3 minus Q1. So if I just do a formula equals Q3 minus Q1 and hit return, this is my IQR. Now my low end is going to be this formula right here. So it's going to be Q1 minus, because we're still going to the left, so minus 1.5 times the IQR that we just calculated. So this 0.34. Oh, I think I made a mistake here. Something just happened. I think I might have accidentally. Let me just undo here. So the 0.34 was the Q3 minus Q1, and so this is going to be this is H6, so L3, which is the Q1 value minus 1.5 times H6. So I don't know why this is. I don't know why this is actually doing this, but it should be negative 0.59. And then this number here is just going to be Q3 plus that IQR multiplier. So Q3 is 0.26 plus, and now I'm going to put 1.5 times IQR, and I get 0.77. And so if I go back to my data set, you can see that negative 0.18 is the lowest number, and that isn't as low as our low threshold here. And our 0.64 is still within the range, so it's less than the 0.77. So we can assume that that none of these were outliers. They may have looked that way, but they're not. So the answer to our outliers question is, if I can go back to that question, is no. There are no outliers for this. Now, is it single peaked? Yes. We looked at this using the stem plot, so we can answer this question quite confidently that yes, it's single peaked. And so now we're going to move on to, and we've already set the significance level. So now we're going to move on to actually solving some of these to determine whether or not things are relevant here. Now, there's a few ways we can do this. One is we can get the descriptive statistics on this data set, and we can do that by, and I'll do it over to the side here, but you can do that by going to your Data tab, Data Analysis, and click Descriptive Statistics, and that will give you this, this table here. Probably not looking quite as nice. I've already pre-formatted this. So we have here a whole bunch of data. We have the standard deviation, the mean, the count, and all of that. So now we need to actually calculate the t statistic on this data. So to do that, I can just, I don't think, yeah, I can just, and actually I'll do it right in this yellow box here. So let's calculate the t statistic. So the t statistic is going to be the formula x bar, which is our mean sample, minus the sample, the hypothesized sample mean, or the hypothesized mean, which in our case was 0. And I'm going to put these in parentheses so that we can force the order of operations. And then that's all over the standard deviation of the sample, which is over here, divided by the square root, and that's a function in Excel, the square root of n, which is the count, which is right there. And I'll close out all my parentheses, click return, and this is our t statistic. Now I can do one of two things here. I can actually go and look into the chart in the table in the book and find what two numbers are bracketing this number. But I can also just use some functions in Excel to do the same thing. So in this case, I'm going to do a t distribution, and now we have a few options. We can do a t distribution just plain and simple, which is a left-tailed t distribution. So that's the left side. If we said something was less than the null hypothesis value, or we could use 2t, which means if the alternative hypothesis had a not equals in it, or we can do a right-tailed distribution, which is essentially saying that the alternative hypothesis suggests that the mean is greater than some value. So we're going to use the right tail because that's what this is implying, is that the mean is greater than 0. So we're going to select the right tail, and we're going to select the t statistic as our x, and the degree of freedom is, and I can do this as a calculation. I can say it is the count or the number of samples minus 1. And then I'll close out both parentheses and I'll hit return. So here you can see that my 0.0468, that is my p-value. That's the magic value that I want to compare to my significance level. So if it's less than the significance level, we reject the null hypothesis and we have sufficient evidence to make the claim that the alternative is actually true. So this is where we would do this here. So we could say that we reject the null hypothesis, or reject H0, and there's sufficient evidence to support HA, or our alternative hypothesis. And what does this actually, what does this really mean? It just means that iGrease works. That's kind of the bottom line. Now, we could have also done this in Crunchit, if you're into using Crunchit. We just like we did all of these other things, we can actually go into the statistics here, and we can go to the T selection and go to one sample. And I can choose my sample as being diff. The mean value, so this is our null hypothesis, I've already established is 0. And the alternative is greater than. So we want to make sure we choose one of these here. And now if I calculate it, we get all of the same values here in in Crunchit. So that is how we can calculate or determine the significance of a particular sample that we've done. I will share this Excel spreadsheet as well so that you have something to use as a template.